All right, what is probability? Somebody can define it for me. I know you got this because it's in your notes, and you just copied it right out of your notes onto the sheet of paper. What did you get?
A numerical value between 0 and 1 inclusive, which represents the likelihood an event will occur.
I don't think I would have said it any better myself. Like if I had just given you the definition, I don't think I could have done that well. A numerical value. Why am I writing this? A numerical value between 0 and 1. This is not scribble. This is high quality work. Between 0 and 1 inclusive, which represents the likelihood an event will occur. Should have left more space. Huh? I put what? A numerical value between 0 and 1 inclusive, which represents, this is represents, the likelihood, this is the likelihood an event will occur. Clearly. Okay? All right. If you're watching this at home, don't show your parents. They may pull out their tuition money and just never pay for it again. All right. A study of 150 randomly selected flights showed 108 arrive on time. One flight is selected. What's the probability it arrived late? Late's the key word here. 108 of them are on time. How many of them are late? 42. What do we call that? There's a name for that. They don't call it late. There's a name for that. Yeah, it's called late there, Dreyer. Thanks for pointing it out. If 108 arrive on time, then 42 arrive late. That's the complement. It's anything other than arriving on time. Okay? So in this case, probability that one of them arrived late, that is 42 out of 150. Now you would simplify that and you would divide each by 2. I'm sorry. It looks like you can definitely divide by 3. And you can divide by 6 if you can divide by both 2 and 3. So let's try 6. Divide by 6, divide by 6. 42 divided by 6 is 7. 150 divided by 6 is 25. If you're really, really, really feeling skippy, you could call this 0.28. Okay. All right. Any questions on that? If 4 dice are rolled simultaneously, find the probability that the sum is less than 5. I know what some of you are thinking. Oh, you put in the word rolled. That makes all the more sense now. No, it doesn't. You're just as much screwed now as you were before. Right, Amber? You don't know how to do it, do you? Yeah, maybe even more so now. All right. Now, James actually does know how to do this one because I heard him tell somebody over there how to do it. If 4 dice are rolled simultaneously and the sum is less than 5, what does that mean, James? If you have 4 dice, then they all have to be 1. That's the only way to make the sum be less than 5. You see, if any of these are a 2, well, that's 5 now. It's not less than 5. So what we know then is that all 4 of them have to be a 1. Well, what's the probability of rolling a 1? 1 in 6, probability of rolling a 1. 1 in 6, probability of rolling... Wait, what the hell? What happened to my complement problem? We'll come back and do the complement problem in a second. 1 in 6 and 1 in 6. Okay. Probability all 4 of them are 1s. What do? Multiply them all together. So 6 times 6 is 36, times 6 is 216, times 6 is 1296.
Yeah. Wow.
What's that?
I played lottery last night.
You did?
No, my parents did.
You lost.
Probably.
No.
I told them that. I said,
Not probably.
Buzz Light or definitely.
You did. Somebody won in South Carolina, so unless your parents live in South Carolina, then you lost. All right, somebody in South Carolina woke up today really happy.
Oh, they won the Powerball last night?
Yeah.
Yo.
I'd give most of it away, honestly.
I'm always available.
Same.
All right.
No,
So there's probability you get less than 5. Now, next question. Next question. Here we go. We got a random number generator. Now, for those of you that don't know what a random number generator, it just generates random numbers. Just in case you're wondering. Okay? There are people who don't know what a random number generator is. Now, it's going to generate 4 numbers, just like 7, 8, 2, 6. Right? Just random numbers. Now, what's the probability that that's the last 4 digits of your Social Security number? Now, here's the deal. Some of you are going like this. Well, I don't even know what my Social Security number is. It doesn't matter. You have one. Okay? It doesn't matter whether you know what it is or not. That's relatively immaterial. What are the chances it generates the last 4 digits of your Social Security number? Probability it gets the first one right? 1 in 10. Probability it gets the next one right? 1 in 10. Probability it gets the next one right? 1 in 10. Last one right? 1 in 10. This is 1 in 10, 100,000, 10,000. Not nearly as impressive as 1 in 1296. Okay. All right. Any questions on that? What's wrong? All right. Did you get these right?
I got that one right, the number one.
You got the first one right.
So I got the first one, I got the second one, and then the number generator. I didn't get the dice.
You didn't get the dice. All right. That's all right. As long as you can get on the test, that's all that matters. All right. 2 cards are drawn from a deck of cards. This is a Texas Hold'em question. Okay? If you play Texas Hold'em and you don't know the answer to these 2 questions, you should quit playing. Just straight. Just don't play. Okay? You play Texas Hold'em, friend?
Yes.
You do. The guy behind you.
Every now and then.
Do you know the answers to these 2 questions? Don't play. Just quit. Okay? Or at least just play for, like, fake money. All right? All right. You play for real money?
Yes.
Do you know the answer to these 2 questions?
I sure hope so.
All right.
If I don't, then I'm very screwed.
Yeah, pretty much. You're invited to my game anytime you'd like to come play. All right. My wife doesn't like it either. She's like, who in the hell counts cards? I'm like, who in the hell doesn't?
Everyone.
How exactly does counting cards work?
I don't know.
Very hard.
Here's the deal. What does it mean with replacement? So you get all these cards, right? 52 of them. One of them is pulled out.
Yeah, 51.
Now, if you do it with replacement, what does that mean? You look at it, and then you stick it back. And it doesn't change how many cards are possible. Now, when you do without replacement, what does that mean? You take a card out, and now there's no longer 52. There's now 51. So that's what it means to do with replacement and then without replacement, okay? Now, I'm going to say this. I assume everybody knows that there are 52 cards in a deck. But let's face it, if you're not a game person or you're not a gambler, you may or may not know that. So on a test, if I give you a problem like that and you don't know how many cards are in a deck, come up and ask me. And I'll tell you, there's 52 cards in a deck. Or if I say we roll a dice, and we roll a dice and you're like, I don't know how many sides are on a dice. Look, no judgment. Absolutely no judgment at all. Why are you laughing? You think it's weird that somebody doesn't know that? No, there's people who don't know that.
Give me the probability.
Probability that somebody doesn't know that, probably about 3%. subjective probability. All right. With replacement, probability you get an ace. How many aces are there in a deck of cards? 4. Probability the people don't know that? About 18%. I guarantee you. Go to Walmart and ask people how many aces are in a deck of cards. I bet you 18 out of 100 don't know it.
Let's not go to Walmart. Questions like that.
4 out of 52 times. Staples is no better. Okay. Remember, 20% of the people can't find the United States on a map.
Really?
Where?
If I'm lying, I'm dying.
That is foolishness.
4 out of 52 times 4 out of 52. That's with replacement.
You got to be a special kind of dummy.
Listen, so wait.
Now you calling 20% of the people. 4 out of 52 times 4 out of 52. Y'all got me all screwed up. I can't even multiply anymore. 1 over 169. Okay? 4 out of 52 times 4 out of 52. 1 over 169. Donnie, what's wrong?
My calculator gave me 1 over 676.
Let's see what mine gives me. I mean, I know what my head gives me. Let's take a look.
But I know that's not.
We got 4 out of 52. Put it in parentheses. Well, you shouldn't have to, no, but it shouldn't make any difference. 4 out of 52. But depending on which calculator you have and the way that the syntax works, I can see that it could possibly matter. Now hit math frac. 1 over 169. If you did it this way, my guess is you ought to get it right. Okay. Because the order of operations isn't affected by that. Okay. Now, how does that problem change to this problem? Without replacement means what? You knock one out. So now you have 4 out of 52. Now here's the thing. This is what a lot of people say to me. But Dreyer, you don't know that the first one was an ace. Well, here's the deal. If I ask you what's the probability that both cards are aces, if the first one's not an ace, well then the probability becomes 0. So in order for it to be both aces, the first one has to be an ace. Now what about the next one?
Has to be another ace.
It's got to be another ace, but it's not 4 out of 52, it's 3 out of 51. Why? One ace has already been pulled out. We had 4 of them already, so now we only have 3 of them left. Okay. All right. Any questions on that? What's that?
So when you was doing this problem, I was like, so he's just saying ace because he feels like it. I didn't even read the end of the question and to see that you said ace. So I was like, what?
All right, so this is 1 over 13, 1 over 17, so that's 20, 21, 1 over 221. Okay. So again, you could do that just by going 4 over 52 times 3 over 51. Math frac. 1 over 221.
I have a question about the complement.
Yes, I haven't done that one yet.
I know. I just never seen a complement with the. I always seen like.
In fact, let's go ahead and do that one right now.
I've never seen a complement written like that.
Like this.
Yeah, I've seen it with like a. I don't know what the thing's called. It's just an A with a. When you, I don't even know the word for it. Apostrophe. Is it apostrophe?
Shoot. Anyway, there it is. You've seen it written this way.
Yeah.
Okay? That's another way of writing it.
Okay, I would have totally understood it then.
We write it this way in statistics. Okay? This way is more set stuff, set notation. Okay?
Gotcha.
All right, so probability of A is 0.05, probability of A complement is 1 minus 0.05, which is 0.95.
They don't call the .05 a supplement, do they? Like they do with angles?
Good observation. No, they don't call that. Complement is 0.05, or the value is 0.05, the complement is 0.95. Usually whenever I show people how to do this in class, they're like this. All right, give us 20 of those on the next test. Just 20 of those, and I can probably get 95. May make a mistake one time just because I make a mistake by accident. Okay. Now, I think we've gotten through all of them but the last two, yes? Right now, you read this one, and you're probably thinking to yourself, I have no freaking clue. Anybody know how to do this one? Greg, what did you put?
You just multiply .13 3 times.
You multiply 0.13 3 times. Nice job, Greg. You see, if we have 3 years, so we'll just call them year 1, year 2, and year 3. Now, some of you are thinking, well, why in the hell is it 13? Where did that number come from? It's just unlucky if a hurricane comes, so it must be 13. No, it's not that. Insurance company estimates the probability of a hurricane hitting land in any given year is 0.87. So there's an 87% chance it's going to hit land. So what's the chances it's not going to hit land? 13%. That's where this becomes such a big deal, right? Okay. So the probability it's not going to hit land year 1 is 13. What's the probability it's not going to hit land year 2? 13. What's the probability it's not going to hit land year 3? 13. So the probability it doesn't hit land any year, or any of those 3 years, is 13 raised to the third. We agree? This is a very small number. In fact, let me let me do this real quick. I'm going to press pause for 1 second. All right. So you know then that by virtue of what we just did, the probability of this happening is 0.00218, or excuse me, 0.0022. Okay? Fair enough, 0.0022. So this is 0.0022. So how likely is it that we can go 3 years in a row, if this is indeed the estimate, how likely is it you go 3 years in a row and no hurricane comes?
Very small chance.
It's a very small chance, right? Now here's my question. So then what would be the probability that a hurricane comes at least once? Say it again. Why is that? But that's for 1 year. Yeah, but that's only 1 year. It's possible that you get a hurricane 3 years in a row, right? And that's 0.87 times 0.87 times 0.87. It's possible you could get a hurricane 2 times out of those 3 years, right? I just want to know what's the probability that we get at least 1 hurricane out of those 3 years. Would it be the opposite of this? And the answer is yes. If this is the probability that it doesn't happen, well, then the opposite of that must be the probability that it does happen. So you're going to do what? 1 minus 0.0022. 0.9978.
So 0.87 should add to 0.9978, whatever
No.
it's cubed.
No. So see, if you do 0.87 raised to the third, what does that mean? That means you've got really crappy luck. 3 years in a row you get hit with a hurricane.
Have fun, you won't have no insurance after that.
Right? That's what that means. That means 3 years in a row the hurricane comes. This means 3 years in a row it doesn't come. 3 years in a row it does, 3 years in a row it doesn't. But what you have to understand is it doesn't have to be just those two options. There are other options as well. Like 1 year it comes, 1 year it doesn't, the next year it comes again. Or 1 year it comes and then you have 2 years where it doesn't come. Okay? So that's how that works. So we're going to do 1 minus 0.002197. And that will be the answer that you see here, 0.9978. Now what I'd like to do is take a screenshot of that. Okay. Any questions?
So on the test, will it matter that